Okay, we're going to look at problem 1292 now. By the way, guys, just try to do these problems on your own. And you know, so if I say I'm going to do 1292, just try it on your own. You've got nothing to lose. Try it. See if you understand it. See if you get some of the stuff right. See if you get the whole thing right, okay? So let's have a look at this problem. It's on the surface, it looks like a complicated problem, but it's actually not. Okay, remember guys, we're engineers. We break things up. We have a certain method, we have a certain technique. We break up complicated problems into more simple problems, and that allows us to solve it. Okay, so what's happening here? There's a girl here. She's throwing these toys. One she throws like that towards the other side of a little pool. Okay, there's a pool here. So she throws it, projectile motion, and it lands there. There's another one that she throws and it lands there. Let's just read this, okay? So the girl always throws the toys at an angle of 30 degrees from point A. Determine the time between throws so that both toys strike the edges of the pool B and C at the same instant. Okay, and with what speed must she throw each toy? Okay, so just maybe pause the video and try to consider exactly what's happening. Okay, so I'm so happy you paused the video. Okay, what's kind of happening here is she throws this first toy at an angle of 30 degrees with an initial velocity, and it has this projectile motion and hits point C, and that takes a certain time. Okay, certain time. Then she waits a certain time and she throws the second toy at the same angle and it hits B at the same time that that one hits C. Okay? So obviously this time for B is shorter than the time for C to get to C. Okay? So she throws this, and then as it's traveling, then she waits a while and then she throws the second one, and they both travel and they hit points B and C at the same time. Okay, so hopefully you got that from the question. Point B is 2.5 meters in the horizontal direction from where she's standing, or from where she threw it, and point C is 4 meters. Okay, and so these are our horizontal directions, or horizontal positions rather, and the vertical initial position is 1 meter. And the vertical final positions are 0.25. Okay, so recall, just try to understand what's happening in the problem and then begin to extract your vertical and horizontal information. And then we try to solve the problem. Okay, so the question really is determine the time between the throws. That's the first thing we need to do. So she throws it, she waits a while, then she throws the second one. What is that time between, while she's waiting? What is the time between the throws? Okay, so how would we do it? We would possibly need to calculate the times of both. Okay, so let me put this over here. Okay, and here is my drawing. Okay, just use your imagination. Okay, so the basic thing is we need to calculate time, the time for each throw. Okay. So let us consider this one first. Let's call this 1, and this is kind of case 1, and we consider case 2. So let's just analyze them separately. Okay, so let's look at 1, and then let us consider our horizontal and vertical information. Horizontal information, what do we have? This is 1 now. We have our range is 4 meters. Okay. Any other horizontal information? No. The only horizontal information we have is that VA in the X. Sorry, I said I've drawn VA here, but actually, let me take that away because we're going to have 2 velocities. Okay, so just ignore that. Okay. Just know that I've got my initial velocity for this one and I've got my initial velocity for that one. Okay, but now let's just analyze only this part, the projectile motion of this particle. Okay, that's because she's throwing it first and then she's waiting, and then she's throwing this one. So it makes sense to me to analyze this one first. Okay? So let's look at our horizontal equations. What have we got? X is x0 plus v0 x t. And let's call this v01. Okay? So this is motion of 1. This is velocity v0 of 1. Okay? So what is x minus x0? If I take that to that side, x minus x0 is my range, and it equals 4. So I've got 4, okay, equals what? v01 in the x, so my original x velocity of this first one, times time. Okay? But remember, the question also is we need our original velocities for both. So what is my v01 in the x? It is v01 cos 30. That's what it is, right? Because we have that 30 degrees there. Okay? So just keep that in mind. So let's rewrite this. 4 is equal to v01 cos 30 time. Okay, so we've got something there that we're working with. Okay? Now let's look in the vertical direction. Again, go through each of those equations that's on the opening of 12.6, that opening page, that first page. Go through each of the equations. Go through the vertical equations. See, am I going to get any information? So what's that first one? Vy equals v0y minus gt. Well, that's the first equation. Will that give us any information? Not really, because I don't have my original velocity. I don't have my final velocity. I don't have time. But the second one, which is y original, okay, plus v01 in the y minus, what do we have there? Half gt squared. That one will give us some nice information, right? Why is that? Because I've got my y positions, my final y position, my initial y position. So what is my final y position? It is 0.25. What is my initial y position? It's 1. And then what is v01 in the y? Well, we know that it's v01 sine 30, right? Just like v01x is v01 cos 30. v01y is v01 sine 30 minus 4.905 t squared. Okay? So can you see here I've got v01 and t in this first equation that are unknowns, and I've got v01 and t in this second equation, which are unknowns. If I rearrange this, this becomes v01 equals, actually I'm not sure what it equals. I thought I had written it down, but I hadn't. Nevertheless, sorry, I'm not going to waste your time by going through this whole thing. But the point is, we've got v01 and t in this equation, and we've got v01 and t in this equation. Okay? Okay, so sorry for that little disruption, but we solve for this. Let's take this. That becomes v01 equals what? Equals 4 over cos 30t. Okay? So we just rearrange this. Remember, we got this from the horizontal equation. We take this and we plug it into there. Okay? We take that, we plug it into there, we get minus 0.75 is, what is v01? It's 4 over cos 30 t. Okay, that is my V01. Okay, times sine 30. And I see now, I hope you saw it, I meant to put a t there, So I put the t there, and I have minus 4.905 t squared. Now what does this become? You can see the t's cancel, and sine 30 over cos 30 is tan 30. So I'm going to have 4 tan 30 minus 4.905 t squared, and that's minus 0.75. Okay, so the only unknown I have here is t, and I solve for t, and it gives me, should give me 0.79 seconds. Okay, let me just make sure. Minus 0.75 minus 4 tan 30 divided by minus 4.905 equals, and then square root. Exactly. So we have 7.89 seconds. Okay, so that is the time it takes for this first one. Okay, now I don't want to make these videos too long, but you do exactly the same thing for this, for that second particle. Okay, first one was there, second one was there. You do exactly the same thing. You've got x minus x0, so this is for number 2 now. This is for number 2. X minus x0 is v02 xt. Okay, and we know that this was 2.5. You do exactly the same thing that you did for the first one, guys. Exactly the same. So that's 2.5 is v02 cos 30 t. What is v02? It is 2.5 over cos 30 t. Then, this was our horizontal. Let's look at our vertical. We use exactly the same equation that we used for that first one. We're going to use for this one, which is y equals y0 plus v02y times time. I forgot that in the earlier one. Minus 4.905 t squared. And we know that v02y, that's equals v02 sine 30 t, right? Minus 4.905 t squared. Y, so the y final is 0.25, y initial is 1, and what is my v02? That's it there. I plug that in there. So I've got plus 2.5 over cos 30t times sine 30t minus 4.905 t squared. The t's cancel out. This sine divided by cos becomes tan, minus 0.75 again, 2.5 tan 30 minus 4.905 t squared. This second time, okay, we can even call it time 2, is equal to 0.668 seconds. So the delta t is t1 minus t2, which is 0.79 minus 0.67. Let's round it off. Okay, so 0.79 minus 0.67 is roughly 0.12 seconds. Okay, so that is the time she throws the first one, and then she waits approximately 0.12 seconds, and she throws the second one. Okay, and then the final question is, what's the velocity? What is v01 and what is v02? So recall, I said that was particle 1, that was particle 2. By the way, sorry, these are meant to be at exactly the same angle. These are both at 30 degrees. Okay, so V01, and there's another vector there, V02. V01 was given by this, 4 over cos 30 t, and V02 was given by 2.5, right? 2.5 over cos 30, that was T1, T2. So that was equal to 5.85 meters per second, and this was 4.32. Okay, so I hope that you've learned something. I hope that you're getting the idea of how to solve these problems. Cheers.